So what I'll often do is I'll make these lecture recordings and I'll try and record the answer to the in-class exercise when I do, so that if you lose your paper or you want to reassess how you did something, you can go to the YouTube video. So for example, this answer that's up on the screen right now, it's on the YouTube video that you can access whenever you want. So everybody, I've already circulated around and we've talked about how what you're doing is you're depositing or paying $550,000 now, and then you're getting $85,000 a year for 6 years, and then you sell the equipment, get salvage of $50,000. So there's 6 years of $85,000, and then a single payout of $50,000 in the future. It's also okay to say that A is $85,000 for 5 years, and then there's a combined, if you put this $85,000 and the $50,000 together, then you could say F is it $135,000? Yeah. You could also do that and get the correct answer if you were doing calculations on that. Okay, and we already took a look at this problem 2. Looked like everybody had $87,155 and 96 cents. And then problem 3, I'll show you how I solved it. The way that I thought of it was that okay, option B is better, because what we did was if you buy the fuel now and then store it, it's going to cost you $260,000. So that's option A. Or option B is take that amount you were going to spend and put it in the bank. And this 20% that it says that's a single 20% amount. That's all of the interest you're getting over the 3-year period. So you're not compounding in this particular case, because it says 20% for the 3-year time period instead of it just being 20% per year. Do you have a question there in the back?
I was just curious why there's like no 3 exponents.
Right, yeah. You'll get really good at learning how these types of problems are worded. Like if it's implying that it's an annual interest rate or if it's for a period. This is the exception, though. This where it's saying that it's 20% for a 3-year time period. That's the only time you're going to see it put that way. Normally when you see a percentage, the default assumption is that that implies per year. So this is the exception. So what it means is that option B is better, because that $260,000 turns into $312,000. The bank magically turns it into $312,000. So you've got that account to draw on to buy the fuel, and even though the fuel is more expensive in the future, you can pay that more expensive cost and still have $47,000 left over in the account. So that's what makes option B better. Just to put it another way, what makes option B better is the bank is paying you a higher interest rate than the rate of fuel cost increases. The fuel costs are going up, but they're not going up as fast as your bank account balance is in option B. Okay, so I'm going to stop talking and continue to give you time to work on the back side of the paper.
I guess, so you added up 12,500.
All right, this problem 4 is a little bit tricky. Let me give you a hint on how to do this one, problem 4. All right, so what we want to do So we want to find out if you're depositing, okay, if you're withdrawing 12,500 for 4 years in a row, then how much do you have to pay back at the end of 4 years? How much should you pay? Now, the amount that you got in year 1, you're going to have to pay more interest on that because that debt was sitting out there for a longer number of years than the other amounts. And so this year 1 amount, how much are you going to owe? Like, just ignore the other arrows for now. What if it was just the year 1 arrow and then this F equals question mark? How much would F be if it was just those two components? Well, it would be 12,500 times 1 plus I to the power of 1, 2, 3, because it's 3 years away. So what you do is you find out each one of these arrows, how much do you owe from that amount that you got? So you could think of it as kind of like 3 different loan amounts because there was 3 times that you were taking money and keeping it for a certain number of years. Let me show you the solution and just see if the form of the solution makes sense, and then you can crunch the numbers on your own too. That's not it. All right, so I'm not even sure where that went. Let me pause the recording. Okay, so the arrow in year 1, it is 3 years away. So if it was just that one amount that you were taking from the bank, then you'd owe $14,470 from that year 1 arrow. The year 2 arrow, you don't owe as much because it only accumulated for 2 years. And so just think about how many years away is it from the year that you have to pay it back. So the amount that's in year 2, it's 2 years away. The 12,500 that you got in year 3 is 1 year away. And then year 4, you don't have to actually pay any additional interest on that one. Kind of a weird loan, right? Where they pay you the same exact time that you're paying them back. Whatever. You received it the same year that you paid it back, but the accumulated amount should be $53,876.56. Okay, so I'm not going to leave this up because I'd like you to run the calculations yourself, but I mean that's the general idea, is that the n keeps decreasing as you get closer and closer to the year that the loan is due. And then this other formula, try seeing if you can figure out what this is implying. F/A, remember we talked about that in class today. The ratio of F to A is this equation. So what that's saying is the ratio of F and A is 1 plus I to the power of n minus 1 divided by I. So if you know A is 12,500, and I guess it wasn't dollars, it was AED, which is United Arab Emirates dirhams. So if you know A is 12,500, what is F? And you can just move the A over to the right-hand side of the equation algebraically, substitute in I, which you know from the problem statement, substitute in n, which you know from the problem statement, and solve for F. So that's the other way to solve this problem. I'll give you a few moments to try that. Okay, so first of all, before I show you the solution to the second bullet point, any follow-up questions to this first approach? The idea of what you're doing is you're moving each arrow through time. This arrow that's in year 1, it has to be moved a period of 3 years to get to 4. And then the arrow that's in year 2, you've got to jump that over 2 periods for it to contribute to year 4. Okay. The other way is to pop it into the equation. You get the same amount. What it says is that the 12,500 as an annual uniform series, if you have that where interest is accumulating for a period of 4 years, it's equal to $53,876 and 56 cents. And it's good when you could solve a problem 2 different ways and get the same answer. That should give you a little bit of confidence. Okay, we got 7 more minutes. And any questions before we move on? Let's just take a final look at the announcements to make sure that that gets in the recording. And I'm going to show you a special video.
When is the homework posted online, the assignment?
The solution to the homework?
No.
So that you can start working on the next one, you mean?
Yeah.
Yeah, I'll post it as soon as I put it together, which I'll probably do that tomorrow. So you have until Thursday to turn in homework 1, and then when homework 1 is in the bank and being graded, homework 2 will be available to you to start working on. And that'll be due on Thursday the 12th, so you'll have a week for that one. Yeah. Great question. No. That was just a one-time thing that you got a piece of paper with the homework assignment. Generally, it'll just be electronic so that we can save trees and all that sort of thing. And so you get it sooner, too.
Will there be emails sent to us, or do we just keep that going up?
I'll send you an email so that you can get an early start on it. Generally, what I'll try and do is I'll try and have it on there earlier than you're going to want to start working on it, just so that it's there as soon as you would be ready to start seeing it. Other questions? All right, so let me show you where I was.